guys, I've made a load test with a hydraulic motor as the load. Just show you now what it is, and then have a run video of the first load. See how it goes. Obviously, still a lot of tuning and stuff, and some other things I'm going to add to it. But yeah, this is just basic now. All it do at the minute is just basically load test. In the future, I want it to work out torque and horsepower as well. So, but yeah, here you go. Give you a rundown. So you've got the driving motor here. I'm just cooling it off with this fan. So I've just done the first run video. But yes, that's the one that we're driving with this Vesc here, and the water's pumping around this PC cooling radiator for the pump around, obviously keeping that cool. This one just measuring the battery current and amps and watts and stuff coming in. Sometimes that doesn't work, but yeah, quite a lot of time it does. So then onto the hydraulic part. I've just got like I suppose you call it like a jack shaft, and 3D printed the sprocket. I tried 3D printing the whole sprocket plus the hub, but it wasn't strong enough and it kept jumping off. So I made this in aluminium on the lathe, and yeah, just bolted it on so I can change. I was going to do a split sprocket, which I might do. I can just print them. I've done the bolt pattern so it can be a split socket. But yeah, so I could take it off without taking this all apart and change the sprocket size. That's a 42 and that's a 16 I think on there. Yep, so obviously that's motor's turning this sprocket, which then in turn is turning this hydraulic pump. So the fluid comes in through here, so that's all full of hydraulic oil. The fluid comes in through this line here, down here, through round into here, back out here, and then this valve is pretty much just shutting, putting the plunger down and just restricting the flow. So as you do that, it creates back pressure in here in the line back to the motor, which then obviously the motor wants to then turn whatever way the motors, the electric motors turning it. And that's why I've got this on here in the load cell, but I'll talk about that later. But that bar at the moment is just keeping that, stopping it from spinning around. I haven't got any pressure gauge or anything on it yet. I will get a temp gauge on the oil as well, because it'd be interesting to see what that gets to. But yeah, that's pretty much the principles. You just restrict the flow of hydraulic oil getting pumped by the pump, which then creates a back pressure, makes the pump work harder, which then obviously puts all that load onto the sprocket, down the chain to the motor. So that's how it's working. Most of the time I'm going to be doing the field windings just off 12 volts with just a little lead acid battery, and then the fans are just run off of LiPo or whatever I had laying around, 12 volt 3S LiPo. Yeah, that's pretty much it. I'll be doing a screen capture of the temps and stuff, but you know, this is just about the load bench really. I'm going to do a better video on actually load testing this to its max. The Vesc 6, I think it's Flip Sky. It's a Flip Sky watercooled. It's supposed to be 200 amps continuous, so see how that adds up. It does actually look pretty good as the results I've got so far. So yeah, any more questions or any comments to make this better in any way? I am going to take it all apart and spray it, but I just want to get it all set up first and make sure it works. So I've got an Arduino running a load cell. This is for later on, for when I put on so I can test the torque and horsepower. So this is the load cell, so that's half a meter long, so I can work out how much weight's being pressed on there, how much torque it is, and then horsepower you just use RPM, and I can't remember how you do it now, but yeah, it's involving RPM as well, and that gives you your horsepower. and that's done through the Arduino, which I have to set up and everything, but yeah, it's all there pretty much. So yeah, cool. Let us know what you think, and like and subscribe if you like the video, and I'll do the load test now. Cheers. Right, so I'm going to do the load test now. I've got the screen capture, so you can see in the bottom corner I will put the amps and temperature of the Vesc. This isn't a full test, this is just testing the load bench. I think if I go to full RPM, it seems to cavitate the pump because it's trying to draw too much oil through and pump too much at one time. So then the pump ends up cavitating, it gets obviously air bubbles inside, so it just stops pumping. So I have to play around with the way I start it, like start it and increase the load, and then increase the motor more and increase the load, and just do it step by step. If I can't rectify this issue, I will probably end up getting a different motor, which I've got one at work, which I think's it's a bigger motor, so it should be able to cope. I'll be able to get some bigger hydraulic lines on there. But yeah, anyway, it's just a little test to see how it works, see what kind of load we can get. Cool. Nice soft start. I'll just step over. I might just move it quickly. Yeah, Vesc just shut off then for some reason. Try and reconnect. I won't. I'll have to reset it. But anyway, that gives you some sort of understanding of how this load bench works. Yeah, I'm just really interested to see later on when we add the load cell and the Arduino and that, try and get torque and horsepower. But I think this just froze. You might better have a look. So it got to 57 degrees. That's pretty good temperature. Yeah, look, you can see it slowly. I don't know if you can zoom out. Oh, it only records a certain amount. Yeah, from 40 to 50 up there. So yeah, we're running at 150 amps pretty much the whole time. That's motor amps. So you can see that was 116 was only 34% throttle. That's because that's duty cycle. So that's the what the motor, what RPM kind of percent that was running at. So 100% would be it's full kVA. So it's a full kV. Sorry. So yeah. But yeah, anyway, we can look back through the through the video and see more. I'll probably show you. So, but I had a limit of, if I see where we current, so there's my limit. So motor current max is 150. Braking doesn't matter, we're not using braking at the moment. Absolute max current is 200 amps. So that's just for like any spikes. So that's probably why it cut out, because it might have hit that absolute max current. So that normally happens where you go really high RPM and bog it down really quickly, and that will spike to over 200 amps, which then will blow the over protection. I don't know if it actually came up in there. Sometimes you get it in the real-time data. Oh yes, it says fault none, so I don't know. But yeah, so yeah, but otherwise looks pretty good, and stay tuned for some proper testing of that Vesc, and I might try some other little things as well, because there's a lot of experimental things in here. So if you go to experiments, you can do like duty sweeps from 0 to 50 in 0.02 steps. Is that time? I'm not sure. Yeah, you can run that. You can run the current sweep from so many amps to however many you want. RPM sweeps, you can do RPM sweeps. So yeah, it's pretty cool. Be interesting to set the load motor at a certain load and then try different settings, and just different, different field voltage windings, and to see how they come out. I'd like to see, because then you can get full results. You're doing a sweep that never changes, it's always the same sweep. So if you get more amps or you get more RPMs with a certain setting or something, could be quite good. But yeah, anyway, if you like the video, please subscribe and like if you do, and I will get on and do some proper testing. Cheers guys.